Seagrass meadows cover large areas along the Mediterranean coastline. Their role in the functioning of marine ecosystems is widely acknowledged within the scientific community. Seagrass meadows offer shelter to several species of fish juveniles, contrast seabed erosion, and annually store about 10 to 18% of the carbon fixed by coastal vegetated areas, the so-called blue carbon. Their economic value on the carbon market, therefore, could be very relevant, ranging from 6 to 23 euro per square meter. This is 5 to 17 times more than that of tropical forests. Unfortunately, according to the most conservative estimates, about 10% of the Mediterranean meadows have been lost during the last century due to trawler fishing, nautical tourism, maritime traffic, eutrophication, and chemical pollution. The impact of these local pressures is being exacerbated by climate changes and ocean acidification. The Medina project, funded by the European Union, is developing new tools for assessing the status of coastal marine ecosystems, which make the best use of remotely sensed Earth observations as well as of field data. Such tools are made available by means of the Medina E-infrastructure, which extends and leverages the GEOS Common Infrastructure, or GCI.
The presence of seagrasses depends on the interaction among several factors, such as water transparency, depth, sediment typology, and wave stress on the seabed. In order to gain a better understanding of the causes of the decrease in the extension of seagrass meadows and to better address remediation actions, the Medina Consortium has developed a species distribution model for Posidonia oceanica, which is the most widespread endemic species in the Mediterranean. The model allows one to estimate the probability of finding Posidonia oceanica in coastal areas, based on a comprehensive set of input data. Finding this data can be very time-consuming, but the resources made available by the GEOS Common Infrastructure make this task much easier.
Medina ecologists are now connecting to the GEOS Common Infrastructure. The GCI Business Process Broker allows for the running of the model through a server made available by the University of Venice and for the searching of the input data in the GCI. In this way, a comprehensive set of input data concerning the North African region has been discovered. The broker includes a set of components that ensure the interoperability among different input data and allows one to download the model output, which is then transferred to the Medina E-infrastructure for post-processing and visualization purposes. The model results are quite impressive. The general pattern of the presence of Posidonia in the region is correctly simulated. A closer look at the Gulf of Gabes, which was once almost completely covered by seagrass meadows, shows that there's great potential for recovery if the main pressures can be controlled. The model can then be applied to other Mediterranean regions and provide a valuable contribution to the implementation of the Group of Earth Observation, or GEO, task Blue Planet.